Relative velocity.
All right, so today we want to look at relative velocity and appraise relative velocity. Now, relative velocity, as the name goes, it is relative. So it is the velocity of a moving body compared with the velocity of an observer. So what it means is that if I have an observer here, so this person is my observer, and I have a moving body like, let's say, a car here. Now, this person will have a velocity, let's say, v of O, and this person will have a velocity, let's say, v of A. So now, I can also have another car which is also moving, and I have another observer. So let's say this observer is stationary. It's a stationary person, and this observer is what? Also moving in the car with a certain velocity, let's say VV. Now, what happens is that how the stationary observer will see this car moving is different from how this person in the car will also see this car moving, either in opposite direction or same direction. And that concept is what we claim as what? Relative velocity. Now, consider two bodies. Let's consider two bodies, A and B. A and B. And these two bodies, they are all having velocities of, let's say, V and VB respectively. So body A is having velocity of VA and body B is having a velocity of VB. Then it says that the velocity of body B relative to body A velocity of body B relative to body A is given as VA, which is simply VB minus plus of what? Our VA. And that is equal to what? VB minus what? VA. So you need to find this. What it means is that we want to see how body A will see body B. So this one will tell us how body A will see body B. How body A will see what? Body B. Okay. Now with this, how fast or slow a moving body is dependent on the state of the observer. We want to look at three cases here. So let's look at case one. Case one is when we have two bodies A and B. They are all moving with a velocity VA and VB. And for case one, we want to look at when they are moving with velocity. Let's say this is moving with velocity of 8 meters per second, and this is moving with a velocity of 10 meters per second. In same direction. In the same direction. Then velocity of B relative to body A. The velocity of B relative to body A, or the relative velocity of B. So you can either act it this way or this way. Or the relative velocity of B with respect to body A is simply what? VBA as VB minus what? VA, which will give what? 10 minus 8, which is 2 meters per second. So what this means is that body A will see body B. Body A will see body B with a speed of 2 meters per second. With a speed of 2 meters per second. And this is what it means. Now what happens again is that if you have case 2, case 2 here is when you have body A, which is stationary. So the velocity is 0. The body A is constant, it's stationary. And have body B moving with a velocity of what? 10 meters per second. So B relative to A becomes VB A, which is VB minus what? Our VA. And that gives you 10 minus 0, which is equal to 10 meters per second. So what it means is that you realize that body A will see body B with its exact velocity. So when it's stationary, you see the exact velocity body B is moving with. And the last case which is the case 3, is that let's suppose we have two bodies, body A and body B. And body A is moving with 8 meters per second velocity, and body B is moving with 10 meters per second, but in opposite directions. In opposite directions. What happens here is that since they are moving in what? The opposite directions, you have to negate one of the directions to find the resultant or the relative velocity. That is the shortcut I can give you. So now let's negate the B so that they all be in the same direction. So if you negate the B, you get negative B, which is what? Negative 10 meters per second. So therefore, B relative to A will give what? VBA, which is equal to negative B minus plus positive what? A. And taking out negative B, VB minus what? VA. And that gives you negative 10 minus 8, which is equal to negative 18 meters per second. So what this means is that body A will see body B with a speed of 18 meters per second. With a speed of what? 18 meters per second. Okay. In the opposite direction. Let's take one example and see how we can deal with it. So this is a typical question, and I want us to look at it. It says that a motorist moves at 16 meters per second, and an observer also moves at 2 meters per second. Calculate the relative velocity of the motorist if they move in the same direction and if they move in the opposite direction. Okay, so solution. So what we are supposed to know here is that the motorist and the observer, they are moving with speed. So let's say this is the motorist moving with a speed of, so the A, same direction, 16 meters per second. And second one is the observer, also moving in the same direction with what? 2 meters per second. It says you should find the relative velocity of the motorist. Relative velocity of the motorist with respect of the motorist. That is, so let's say the motorist is what? Vm. The velocity, and this is VO. Therefore, Vm with respect to the observer is Vmo, which is what? Vm minus what? VO. So Vmo simply becomes what? 60 minus 2, and that gives what? 4 meters per second. So that, which means that the observer will be seeing the motorist move with a speed of what? 4 meters per second. Now the second part is that they move in opposite direction. They move in what? Opposite direction. And what this means is that if the motorist moves with a speed of 16 in this direction, the observer will move in opposite direction. VO, which is 2 meters per second. So we can negate one of them as we did earlier on. So therefore, let's negate the observer. So if the motorist is this way, 16, and we change the observer to the same direction, we negate his velocity as negative 2 meters per second. Sorry, this one, the answer I give you 14 meters per second. 16 minus 2 is what? Is 14 meters per second, sorry. So now, when you do this, Vmo becomes negative what? Vm. So it becomes Vm minus negative VO. I get it because the VO is already negative. So you get what? Vmo as what? 16 plus 2. And that gives you 18 meters per what? Per second. So therefore, the observer will be seeing in opposite direction. The observer will be seeing the motorist move with what? A speed of what? 18 meters per second. Thank you.